Hi everyone, are you able to hear me? Great, great. Today we are going to do something really important. All right, let me start sharing my screen and then we will discuss it. Wonderful. Are you all able to see my screen? Hi, I'm so glad to have such a wonderful audience. And I'm sure that you're going to learn something really important today. So welcome all. In these sessions, we get thousands of viewers, and it's going to be for around 2 hours. And it's going to be very important that this session is going to be extremely hands-on. And we'll try to explain the concepts. It's but the concepts will be really brief, because this is a very experiential workshop whereby I'll walk you through line by line the entire process of how would you build your own custom machine learning model. Okay, this is something extremely important in today's time. Uh, we all know that there are pre-trained models, there are all kinds of ready-made stuff, but instead of developing fear of a custom machine learning project, you should build a habit of working with the entire process. It's actually pretty straightforward, simple, and I can bet on that you will all enjoy this process. Okay, so wonderful, and welcome again, all of you. And stay tuned. I'm going to walk you through the entire process. All right. So let me move the comments to my. Okay, I can see your comments on YouTube. Hello all. Wonderful to have such a great audience today. And feel free to ask questions in the context. And I mean, why it is important, let me just explain to you that again, why this project is very important to all of us. Uh, Whenever you are joining somewhere as a machine learning engineer, data scientist, or data analyst, or senior engineer, there you will always find a need of good engineers. Let me just check if my audio is in good shape. All right. Yes, my audio is in good shape. So so whenever you join as an engineer, you will find that the machine learning project has become very common, and there is a difference from like standard software engineering process. There is a difference with respect to the steps, with respect to the objective, and so on. All right. So let's get into it before we, discuss anything else. So. All right. So first of all, welcome to CloudxLab. CloudxLab is into cloud-based lab, and we have everything around it, right? So on the cloud, we have provided a lab which you can basically, if you just go to the lab page, you can just take a subscription. Everything is on the cloud. You can learn any of the tools or technologies and so on. So you can just take a look at the lab. So this is a plain vanilla lab, but the great part about the lab is the assessment engine. So we have created an assessment engine and projects around the assessment engine so that it checks your work immediately and gives you feedback. And that way you really learn, learn a newer technology. You overcome inertia to code. You overcome inertia to try hands-on, and therefore so you get a lab without any installation. You get question on the theory without, at the same place. Third, it guides you. It gives you feedback that whether you are wrong or right. That's what we are going to do today. I will take up one of the projects. and I'll walk you through that. All right. And it keeps on giving me points. So right now, whenever I do something, it basically gives me points. And that's something, you know, I mean, we have a good social network here. So if you are performing great, it'll reflect upon your profile, and recruiters will basically try approach you. Okay, so that's a kind of social network between the learners, the the recruiters, and I mean our content and the instructors. Okay, so it's like that. So you can also, if you are an instructor, you want to create your own course at CloudxLab, do reach out to us. We would love to help you out because anybody can create their own course. Okay, so at CloudxLab, so feel free to reach out to me or reach out at our general email ID, reach us at CloudxLab if you are planning to create your own course. Or even if you are don't want to reach out, just create your own course. It is pretty straightforward. You will enjoy the journey. All right, so we are going to explore the courses. Okay, and yes, I want to just tell all of you that those who want to take a full course, want to get a certificate and so on, you can basically take up any of those. Okay, and you browse around and figure out what is suitable for you. And if there are doubts or questions, you just reach out to us. Perfect. Let's move on. So this is where you get the listing of everything here. Okay. And there, let me select the tag called guided project. And then I select machine learning. Okay. So these are the machine learning guided projects which are there. Okay. So, right, this is one project on bike rentals. This is another one to classify clothes. These are all machine learning, deep learning projects. And this is a project for building like cat versus non-cat, cat as in the animal. So here you build it, and there is a Titanic one, there is a spam classifier, there is California housing. This is the one we are going to take today. All right, this is the one that we're going to take today. Okay, so let's start. So this is a quite good project because it's in this project, what we do is we are given a data set of a state. Okay, basically state of California, we are given the state, and now given the housing data. Based on that, what we have to do is we have to build a machine learning model which can predict the 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 value of the house given the district information. So it will learn from the districts, the given data, and create a mental model based on various parameters, such as how many rooms are there, which area is it, what is the income group of people, how far is it from the sea, and so on. Okay, so this is a extremely important project because it's going to give you a good perspective of machine learning, specifically supervised machine learning. Those who are not aware about machine learning is essentially training machine from the previous historical data so that the machine can do the prediction. Okay, that's exactly machine learning. Machine learning is a bunch of software algorithms, and basically these algorithms. To these algorithms, we feed the historical data. We frame the historical data in such a way that these algorithms can accept, and then once it has learned from the historical data, it would be able to predict predict the values of unseen data. Okay, so the way you can think of it, I'll show you the format of this. So you have historical data, you feed it to the model, you feed it to the algorithm comes up with a model, and once we have the model, we can feed it real-time data or unseen data, it can give the results. So this is the kind of T-shaped model. Okay, nothing magical. I mean, nothing so complex about this process. Okay, it's essentially just like humans. Based on historical data, we learn from it, and Once we have learned, then we can tell the answers for the unseen questions. So we do it day in, day out. Like, for example, in the beginning, we learn from a book that 2 plus 2 is this, 2 plus 3 is this, 2 plus 4 is this, and so on. So this is essentially the data that is being fed to us. And then once we have learned the meaning of addition, subtraction, division, and so on, when we are given a question, we can answer it. Okay, so it's exactly that way. Just like humans learn, similarly, we have figured out these algorithms that can learn from the data, historical data. So we will, in this project, we will show the algorithm that this is the history, historical, like for this particular district in this like in this neighborhood or district, this is the price of the house, and these are the parameters of the neighborhood or district, and then and so on. So we'll show this information or to the algorithm learns from it. Once it has learned, then given a district, it can give the answer even if it has not seen it before. Okay, so that's essentially the idea of machine learning. Okay, so those who are coming from software engineering background, they will think that what if the object is not there in our database, we should not give the results. Here we have to give the results because it's not like a hash table. Okay, in hash table you put the key and the value, and when you provide the key, it should give the value. But if the key is not found, then the value is not provided, right? In case of machine learning model, we give the key. Key is like input data and give the value. Key is the input data and the value. And then it learns from it and creates a mental model of it. And then when we give a key, it approximates to the right value of it. Okay, instead of just giving the value. So that's another way you can look at the machine learning. All right. So with that in mind, let's move ahead. In machine learning, there are different kind of machine learning problems. One of the machine learning problems are they're called supervised. In supervised, we have label as in this house has this much value. The value is the label. Okay, and right. Or let's say we are training a model to tell which fruit is it. Okay, so given a photo of the fruit, it has to tell which fruit is it. Right. So if we have historical data of photo which is labeled with the fruit name, like whether it's apple or guava or mango, that's the label. Okay, so we have label and features and so on. All right, so the way we structure the historical data is in this form. We have instance means one experience. Okay, one experience is in one, in this example it will be one district. That will be the instance. Label is that what is the value of it. What is the label here? Label in this case of housing project, it is the value of the house. So, and the features are the characteristics of this particular district or the area. Okay, each row is one district in this example, and so on. And when we say historical data, it's essentially lots of such instances. All right, let's move ahead. So this is the project that we are going to work with. All right. All right, so where did my questions go? All right, let me just pull out the questions. Just give me a moment. I think I closed the YouTube video. Okay, let me just go there. All right. Okay, so let me take out the chat. No, it's all good. Perfect. Perfect. So let's get started. And all right. So I would say that you be with me instead of trying to do it alongside, because right, you would get distracted. So you can watch this video. This video is going to be available on our channel, and do that. But focus on the ideas, focus on the concept, so that you will be able to ask questions and so on. Okay. Also, one more important thing is that when you do this project by yourself and you solve all the steps, you will get a certificate by itself. Okay. And we have a free lab trial, those who are wondering. So you can just sign up with the lab, and it's just $1 you have to give from the credit card, and it'll refund this probably in 5 minutes or so, and you will get a trial period for this. Okay. And if you like it, you can take a full subscription of the lab. All right, let's start. So on the left-hand side is the theory, or you can say the concepts and the problem statement. On the right-hand side, we call it Jupyter Notebook. Okay, those who are not aware of what is Jupyter Notebook, it's a kind of nice user interface. And it's a standard as of today. Every machine learning engineer or machine learning data scientist or machine learning researcher spend their time on Notebook most of the time. Earlier, people used to use Python command line interface. Okay, those who are familiar with command line interface, they can just go to console and start the command line interface. Also, we have guided steps for almost every technology that's there in CloudxLab. So you can take a look at in your courses. So if you say 1 + 1, now you see 2 here. And please note that this is not a constrained environment. Okay, this is a real environment. This is how you will see when you go to join a company, work with them. So you'll get basically a similar environment. Here you can run anything you want. Okay. Similarly, you can store the data, but this data is something, it should not be like your own very confidential data, because sometimes when you get stuck or something, we do have to log into your account to resolve it. So the data here is not really, you should not put any confidential or private stuff here in the lab, because right, for me, you can see that there are files and so on. And these are persistent files. It's not like they're gone after the session. They remain. For me, it's like for quite some time, the stuff is there. I will try to delete these things, and probably, yeah, I'll do that. I'll do that. Okay. Okay, never mind. So we'll try again. All right. So this is the notebook. Okay, if you want to change the kernel to something, you can change, but this project would require you to use Python 3. Okay, so here you can try any Python command. Okay, any Python, you can say expression or statement, and it works pretty well. Okay, you will see that. So, and those who are wondering that, is it the only environment we get? No, you can just, go to my lab. Okay, you can go to my lab, and there you can launch the Jupyter, which is independent Jupyter, and you can use that. Okay, and that's about it. So coming back to where we are. So this is our end-to-end project on the machine learning. So good. So we learned about a couple of things. So we would like to go straight into this problem. Okay. And those who are not very familiar with Python or other things, do not freak out, do not worry, do not get upset. Trust me, when you just try to follow it, you'll be able to infer the meaning of it. It's like, you don't have to follow, you don't have to use the dictionary while reading every fiction book, right? Every book. You can just correlate the things. Similarly, here, you will be able to correlate. Okay, so wonderful. So basically, let's first of all, we are going to import a lot of things that are needed. Okay, we're going to import a lot of libraries that are needed, and then we will go on to loading the data and other things. Okay, so it says that let's import a few modules, set a random seed so that the code can produce same results every time it is executed. Okay, so we will also set RC parameter to change the labels like this. Okay, all right. Basically, the matplot is a library to display the nice colors, right? The nice plots. This is a good setting to have. Okay. All right, let's start with we will right. We will import scikit-learn, NumPy, pandas, and so on. Now here is the code, right? It's import. This is sklearn. Okay. We'll just give it np as a name. Okay. And this is pd. So basically, we are importing a library called NumPy, and we are importing a library called pandas, and we are importing a library called scikit-learn. This contains algorithms, right? Algorithms for machine learning. This is basically an array. Array is nothing but sequence of values. So NumPy provides that very robust and fast array in which we can keep the values. Okay, because Python's array is not that efficient when it comes to doing mathematical operations. Okay, and therefore almost every library in machine learning or any kind of data processing, they use NumPy. Pandas provides you a data frame just like SQL database table. Okay, so it has columns and it has rows, and you can do all kinds of things like filter the rows based on a logic, filter the columns, pick the columns, add more columns, delete some columns, delete some rows, translate it, group it, and so on. So all kinds of things for data processing, you would be using pandas. And NumPy is essentially an array which any algorithm in scikit-learn, they will accept data. They will accept data in the form of NumPy. So using pandas, we clean up the data, load the data, and then translate it to NumPy, and then give it to scikit-learn. Okay, so so you can say that right, like in pandas, we do the cleanup of the data, and then we basically give it, convert it into, let's say, NumPy array, final one, and then scikit-learn algorithms. Okay, this is not a code. I'm just putting a comment in front of it. Okay, so now you have to run shift enter in order to execute something. Okay, now it says that you have to set seed. Okay, so seed is nothing but you basically can you know, let's say I'm putting 42 here. Okay, so every time the seed is there, right, and I've said np dot random. Okay, and okay, random. Okay, so you can see that if the seed is same, it'll keep on giving the same result. You can see between 0 and 1, it has given 7. If the seed is same, it'll give the same results. Okay, and if you change the seed to say 41, the random number generated by the second one is different. Okay, so it's essentially a pseudo random number, and that's how it is. So I'm going to go back. This is an example of how to use the meaning of the seed. All right, now one more important thing you will notice is that we are using Matplotlib. What is Matplotlib? Matplotlib is essentially basically Matplotlib is essentially a way to do the plots. Okay, so right, it says that you know, MPL, import it as MPL. Okay, make sure that the variable names are same, otherwise the checks will fail. Okay, so these, all right, so we have imported Matplotlib, and then we are setting various settings. Okay, all right. There is a question from Krishna that Are we learning database SQL connection also? Not really, not really. But you can definitely do it. It's not going to be a big deal for you, trust me. All right. And if you just follow the tutorials, okay. So it says that it says that set RC parameters, okay, RC parameters, and we use RC here, okay, just like we have mentioned here. So we basically setting the labels and other things onto our plot. Now, the final thing is that we will import warnings to ensure that non-essential warnings are ignored. Okay, this is to ensure that the process is cleaner. Okay, so here now we are all set up. Let's just see if I am able to do it. Okay, so it says that yes, it is working. So I got some points, 100 points. Okay, now moving ahead, this is like first step. Like whenever we are working in machine learning project, the first thing you do is the first thing you do is that you basically go stepwise. Okay, first thing is you import the data, import the libraries, then you load the data or import the data, clean that up, translate it, and then you follow the machine learning process of splitting the data into training and test. Okay, so be with me and I hope everybody is in the context. All right. I'm guessing that everybody is in the context, so that at any point of time, if you have any doubts or confusions, do let me know. All right. Perfect. Perfect. I'm super happy to have such a great audience today. And let's just move on. Perfect. Now, the end-to-end machine learning project that you see here is that okay, so I'm just checking the questions if there are any more questions. Perfect. Now, the next step, so we crossed two steps. Number one, understanding what exactly the project about. The project is about predicting the values, predicting the value or the house price, and we will see it as we go ahead. So we did our groundwork, we imported all these and cleared the first step. Now, let's load the data set. This data set that you see here is located in absolute path. Okay, this is the absolute path. Okay, so you can usually use a tail command if you put exclamation mark. Okay, you see that this is our raw data. Okay, we don't know what are the meaning of these columns. Okay, similarly, you could use a head command to understand what's going on in this file. You can see now it makes sense. So this file is inside the top label directory called CXL data, inside datasets, project, housing, and so on. You can also go to say console and check it there. Okay, you can, let's say you want to see are there any more folders in this and so on. So you can use the Linux commands. So those who are not comfortable with Linux, we have a free tutorial on Linux, which is very powerful and which is very useful, which teaches you these basic commands so that you get comfortable. And my request to all of you would be that make sure that you are comfortable with basically the machine learning, with the Linux and everything. So if you go to explore courses, there you will find, let's say if you take a look at Linux, okay, you will find these nice playlists. Okay, so this one is one, and right, these are all others. So you can take a look at these. Okay, and not this one. These are like full-fledged training courses. You can take a look at that. This one is the one which you can learn from in order to learn these Linux command if you're not comfortable with. All right. Of course, if you complete this project, you can request a certificate here, okay, after completion of this project. And then once you request this certificate, you'll get the certificate, and then you can basically put it in your CV, okay? And you can also post it on LinkedIn or anywhere. Like every day, hundreds of people do that. Okay, so it is quite useful because I believe personally that if you follow all the steps of this particular project, you will definitely learn a lot. Okay, now let's move ahead. So we checked that this file exists, and we also checked ourselves, oh, these are the folders existing. And now it's saying that, okay, define the housing path. Okay, housing path should be in the double quotes, this file name. Okay, housing path variable to the path given to the dataset above. Yes, this is the one. Let's run it. Okay, let's also check if this variable has been defined. Yes, it has been defined. It's a Python variable, all in caps. Okay, now is the important part. So this file, this data set that when we saw using Linux command, it's comma separated. You see that? This is comma separated. Okay, longitude, latitude, housing, and so on. It has the first line of this file contains the columns, and these are the various parameters in the house in this data set. Okay, so we'll use as it says that read CSV is something that we can use in order to load it. All right, so we have loaded this using pandas data frame. Pandas using this, we have loaded this into our data frame. So pandas has a method called head. You can take a look at all functions by pressing tab. Okay, so essentially it will show you all these methods that are available. Okay, and in case you are not clear, let's say ABS, what does it do? You can always put a question mark and it'll show you the hint and answer. Similarly, if you do not know what are the methods in there in housing, you can just say dir, it'll show you all methods. All right, and then you can also say help, and let's say this method. I'm just showing you what exactly does, like how would you seek out the help. So here it shows you exactly what it means. Perfect. So you don't have to leave the environment. Of course, you can search it at on Google that how to read CSV using pandas, but you don't really need to. You can just go through the library functions, look at the help documentation, and look at the list of it. This way you will basically, this is the only way to learn anything. Just explore things, know what is done by who, and when you need it, you'll be able to recollect, oh, I saw this that other day. Okay, so now let's just move ahead. So let me okay, go down here. So we loaded everything into housing, right? So this is our housing data set. Now you can see this thing very clearly, right? Each row is representing a location or a district. It shows that this is the location, longitude and latitude. This is the age of the house, median age, like since it's a group of houses, so what is the median age of those houses? Total rooms, total bedrooms, right? Total rooms as in the total rooms in the whole area. So this is not per house, okay? This is a group of houses, okay? Total bedrooms, population, and it's one district, one row, okay? And household, median income, and so on. All right. Question is, I want the PDF of this project. We do not have a PDF of this project, but you can basically copy paste it into Google Doc or some other thing and create this thing. Also, once you are done with your project, you can download it. Download this as a PDF. All right. That would also be a good idea. All right, and right, or you can download it as HTML, Markdown, or any other format, and you can also convert it to Google Slides. Okay, in Slides, not Google Slides, Slides. All right, I hope that is helpful for you. And yeah, also this is a public project, so you can just share the URL with your friends. And in case you have any doubt at any point of time, you can just come here and put your comment and ask questions to people. Okay, So I'll just pause the screen for a moment because I have a question from somebody. All right, there are no questions. Perfect, wonderful. These are very important points. So one of the questions from Krishna is that instead of CSV file, can we get the input historical data from database and predict? Of course, of course. So I think if you take a look at I'll just show you something in case you are worried about it. So like SQL at CloudxLab. Okay. So from here, this is where we have shown interacting, getting started with MySQL. No, not really. I recently did, where exactly is my post? It should be a blog. Okay, so in case you're wondering like how to load the data into Jupyter, using that, it was there. Yeah, how to access databases using Jupyter Notebook. Okay, try that out and it should be possible easily. Pandas allows you to load data from all kinds of places. All right. Yes, of course, you can share the webinar link as well as this project with your friends. Okay, so you can just share it with your friends. And yeah, all right. Now coming back to where it is, and basically this is how the housing looks like. So we have successfully loaded it, and it says that display few rows using head. We have already done that. So let's just try submitting the answer. I think it will pass. Nice, gave me 100 points. Perfect. Now moving ahead, so all right. So now moving ahead, so right now we have loaded the data. First we imported the data. Now we imported the libraries. Now using those libraries, we imported the data using pandas. And we have a bit more clear picture of the problem that we are trying to solve. Okay, now we will try to explore the data set. Okay, now we'll explore the data set. We'll be using the history method, the histogram method. It will plot the histogram. A histogram, you basically, whenever you see the data set or any range of values, try to plot a histogram on it. Okay, so that you can quickly say that 90% of the users are this side and 10% are like that. And that way, that's like basics of analytics, right? Like, for example, you're given the data set of say COVID patients, right? So you can quickly take a look at the histogram and say, oh, it's mostly the people who are of this age group who are more susceptible to COVID, right? So that kind of analysis can be done pretty simply if we plot the histogram of the data set. As a thumb rule, you do two things. One, you plot the data on certain coordinates and you plot the histogram. Okay, so I'm not going to do too much theory, because this is for, like, this is very exponential, as in it's going to be something where we do the things hands-on. All right, because theory is just too much. There's like whole internet is full of theory. This is going to be more practical. All right, now, so basically histogram methods has bin parameters, like how big. So what histogram is, if you have a range of values, you break it down into like buckets, and in the buckets, for each bucket on the y-axis is the height of each of the bar is essentially the number of people who are there in that bucket. Okay, I'll just show you, then you'll get an idea. So So that bins parameter is essentially that. And we will also be using cut method from pandas. Okay, this is used to segment and sort the data into bins. Cut is also helpful for converting from continuous variable into categorical variable. Now, don't worry about these two keywords. So continuous variable is like the values like 1, 2, 1.4, 2.4, 3.5, things like that, right? Any column or any feature or any characteristic of something which is continuous or numeric. It's basically a continuous. Categorical is something like high, low, good, bad, red, yellow, things like that. Okay, categories. Okay, when you see on the internet that drop down is generally for categorical variable, the input parameter like a text box is essentially for the continuous variable in a form. Okay, that's how you can visualize it. Like for example, using cut method, you could convert the ages of group like ages of groups of age ranges, and it supports this. Also, there's a label parameter if you want to customize it. Let's move ahead. Also, there's a nice cool method when the moment you load the housing, all right, the moment you load up pandas data frame. This is basically a pandas data frame. We loaded it from using read CSV method of the pd.read CSV. And this is the object that contains our data frame that we recently loaded from that file. And this is in memory, by the way. It is kept in the memory. Now this one, you see that info gives us very cool information about housing. You see that? So here, basically it says the like how many values are there. Okay, how many values are there and how many non-null values are there. Okay, so you can see these values. Okay, so longitude has these many non-null values, latitude has these many non-null values, and right, and so on, right? And so you can see it clearly that there are total these many entries, and here it is. Okay, the only one who is the problem is total bedrooms. Do you see that? This is the only one which has some values which are null. Okay, out of like uh, here it's 20,640, here it's 20,433, meaning that there are some values close to, I think 300, 200, close to 200 values are null in this one. Okay, we'll learn how to deal with that. So you can see that using head method, you can see few rows, and using info method, you can see the information about this. Also, it shows the data type, it's float 64 and so on. Sometimes even like for some of the ideas some of the algorithms or the data sets, we may want to say that don't load it at float 64, load it as a lower float value, because float 64 takes a lot of memory space, and like it takes 64-bit. You can use it like 16-bit or something if the memory space is precious for you, like in memory, like RAM. All right, now let's go ahead, get a better understanding of mean, deviation, maximum, and so on using describe method. Now, a third cool method about a pandas data frame is describe. Okay, now you'll see the difference. Now, describe is essentially, telling us lots of things about each column. So we learned that our housing data set looks like this. It has these columns and it has these many rows. It has these many rows, these many columns, and these are the various values in it. Like this one is like text value. Okay. Now we saw that there are some things that are null. Then there are like when we look at it, it shows. Now you can see that clearly that for this column, there are total values are these many. The mean is this. Standard deviation is this, minimum is this. Standard deviation means how much variance is there in the data. So it looks like not too much variance here, okay? And similarly in the latitude, while in total number of rooms, the variance is very high, okay? Perfect. And you can see that like at this value, okay, like at this value, right, within this value, there are 25% of the, houses. And at this value, 118, there are 75% of houses. Okay. Similarly, you can also understand the behavior on every like the values of each column. Okay, so we got mean, minimum, maximum, we got the quartiles, we got the idea about the data frame. This is a very, very important, uh, thing, because this is like when you go to I mean, whether you are engineer, data scientist, analyst, a machine learning engineer, or there's so many machine learning researcher, this is where you start. Okay, you must know about these things. This is going to be extremely helpful for you. All right, so let's move ahead. So we understood these parts. Now, next is, let's try to plot it. This is the third, like next thing that you would usually do. And we will say, here it says that plot histogram of all the features using Hist method. So we are going to just do the Hist method. All right. Now, please note that what is that we are trying to do in these columns, right? In these columns, what we're trying to do for each of them, we want to see how the values are distributed between various buckets. Okay, so it's going to break down the data set into 50 buckets and try to plot a graph in which the values are on x-axis and y-axis is the statistics. Okay, I hope the font is all good to you. Is it clear? Because I'm not sure if I can increase the font. View. Okay, add it. All right. If I increase the font, what will happen? All right, I can just, okay. Now you can see. So we plotted this histogram on the data. So household, you can see there's a peak here. For this one, there is a peak here, and so on. You notice this end one, right? Whenever you see this kind of edge case, usually most of the things are of like a bell shaped. Why? Because the things like, let's say we have a class of students and we plot this graph on for the students, right? So there will be very few students who will get very few marks, like out of 50, 1 marks or 2 marks. There'll be very few people who will get like out of 50 full marks, like 50 out of 50. And there'll be most of the people will be like in the middle. So the plot will come like a bell shaped. And most of the natural things in the world, in the natural world, most of the things are essentially bell shaped. Okay, so what you see here is this one is good, but this one is a little crazy. You see that suddenly at the edge there is sudden high, right? Whenever you see this kind of thing, you should be aware that there's something crazy going on here. Okay, so actually there's nothing crazy. What's happening is that all the values that are high, the values that are higher than this, okay, they're all being clipped here, right? In certain data sets, what people do is that any value above 50, mark it 50. Okay, that's what has happened here. Similarly, any value above 50, 500,000 is clipped to this value. Similarly, there's a clipping of the value. All right, so we will have to be careful when we feed it to the machine learning. Probably we can just delete this or ignore this, so that we do not, our model doesn't learn from it that, okay, if it is here, the model goes mad that I don't know what to do with it. Okay, so be careful about it. Similarly, here you see suddenly it's going up at the end. You see that in case of median income, it's written median income here and there. Okay, all right, I'll just try to see if I can. Okay, All right. So this is the median income. And then total rooms looks okay. There's a long tail and there's right? There's a bell curve. But here it seems to be that there is something clipping going on here. But that's okay. This looks very neat. This is also okay. This is also okay. You can see most of the things in the nature have this. Just that in case of longitude, there is something like we call that multinodal or multimodal, as in there are multiple towers in it. These are all unimodal, unimodal, and so that, right? So you can see that this is actually, this gives us a very clear perspective of how is the distribution of the data in each of the columns. Okay, whether you, all of you, whether you are coming from a data analytics background, BI background, whether you're coming from like software engineering background, whether you're coming from full stack developer or machine learning researchers, or whatever background you are coming from, this is going to be extremely useful for you. And if you are like statistical background, this is something that you will see, oh wow, this is like this is so easy to do it in using Python and pandas. So you will appreciate that part. Okay. And yeah, those who are from, let's say, our background, I mean, we do not have a separate project for them, but they can use the R notebook in case of Python, but the auto evaluation will not be available in there. Okay, so now you can plot the histogram of all the features using Hist method. Okay, so here the question is, question here is, we have already done that. So this is histogram. Bins means how many bins do you want? You see this? This is one bin. The streak that you see, it's a single bin. Okay, it's a bar, one bar. You see that? So what it has done is, we took the values, like cut the whole range into 50 bins. And for each of the bin, it computed how many values are there in this bin. And that those number of values go on the y-axis. X-axis is that bin value. Okay, so you can see that this is one bin, this one streak. Okay, so it has broken down the entire range into 50 and then do that. This one figure size is 20 by 15, 20 horizontally, 50 this is 20 by 15 pixel, or you can say that 15 centimeter, I don't know, or 15 millimeter. All right, I really do not know. I think it's some units, because 20 pixels is not this much, right? Anyway, moving ahead, you can try increasing the figure size. Okay, if you just put this, let's see how it looks. Will it look very horrible? Okay, it's going to take time. I increased the figure size. Okay, it has gone crazy. In case your kernel goes crazy, what you can do is you can go up. Oh. Yeah, here you can say interrupt. Okay, if your kernel goes crazy. But I don't think there is a good reason for interrupting. Okay, let it finish. Now you can see that the figure size is increased or something. Okay, but anyway, we interrupted. So all okay. Now, in case you are okay, you can also decrease the number of bins. Let's say I decrease the number of bins to 5, and then I'm plotting it. Let's see how it looks. Now you can see these bins are bigger. So you can see most of the data here in case of household is between 0 to this much. And now from this, you can see that how your data is further distributed. Okay, so you can see that basically we converted it into discrete values. Okay. Or let me just go back to 50 and let it be there. Perfect. So now is the time that we basically plot the histogram of median income. Okay. All right. So what we did was we did on the whole of the data set. Okay, we can also plot the histogram of one particular column rather than whole data set in the using the same mechanism. Okay, and we can say plt.show, right? So you can see this is one. Okay, for some reason here it has not really honored the size of the this we have given. Okay, all right. So next task we are given is divide the median income attribute into bins and label using cut method. Okay, so here we go. And all right, so we are saying pd.cut. Okay, so we are basically converting something called median income. Median income looks continuous, right? There is a value 0 up to 2, 3, 4, 6, 8. Also, you can also take a look at, say, the describe method. It'll show you these values clearly, or using info that you have seen above. All right. Okay. Now, let's move ahead. Hey guys, my video is visible, right? Kirti is not able to see the video. I hope everybody else is able to see that. Okay. Now you can see this. Very nice. This is an important one. So what you see here is that we are basically taking the median income column, breaking it down into these bins, and putting these labels on them. Okay. And this is how it looks like. Okay. So what you see is this is well discrete diagram. Perfect. So what you see is here we have cut this into these bins, and then we simply did histogram, and it looks really neat. Okay. Now moving ahead, let's see if it works. I'll check if I have defined. Also, one more thing that please notice here is that right here we are defining, adding one more column into housing dataset called income category, which was not there above. We are creating that using cut method and basically converting the continuous variable into categorical variable. Here, the values in median income are continuous, like 0, 0.1, 0.2, 0.3, 0.4, like that. Here, it's like 1, 2, 3, like that. 1, 2, 3, 4, 5, like that. And that's how it is. So basically, we converted the continuous variable into groups. Perfect. Now, so we have already cleared it. It was success. And now we move ahead. Okay. We are 5 out of 16 steps away. And in this step, we'll split the dataset into training and test. We'll be using the stratified sampling. Okay. Notice one very important part. If you see here, that there are very few people in the lower income group. This is income category we have just created from the median income. So what is this column? This data set is essentially one row representing one district. Okay, so the poorer districts are lesser in this data set. Okay, that means that this data set is biased towards the rich districts. Okay, even the upper end, you see this upper really high end has more number of districts as compared to the lower one. You see that? Therefore, the representation of the lower districts is very low. And right, you can see mostly are here. These two groups contain the maximum number of districts. Therefore, this is what causes the bias in your model. And you have to be very, very careful with it. If you're, let's say you studied from, let's say I come from a place where women are not very, women are not present in most of the engineering section, right? So my mental model would be that women are not good at engineering, right? Right? Because I inferred my, I inferred my statistics from a skewed data, from a data set where there was a missing data. There were not many women who were going to college and so on, right? Therefore, I created a mental model. Similarly, our model, the one that we are training just now, could also go basically biased, right? Because here it would see that, oh, there are only few people in this smaller category income group, okay, and it'll basically ignore that and so on. Therefore, we have to be careful while training, testing, to ensure that number of instances from each of the income category are present in everywhere, okay. And this is one of the very, very important parts about machine learning. Because you understand that, okay, there are differences like this, and therefore you have to make sure while you are splitting data set, you have to do the stratified sampling. Okay, what is it that we are trying to do? Now we have seen the data set, and we have seen like cursory, like we've understood the basics of our data set, what it is about, and how is our data distributed. Now is the time that we split the data set into two parts: training and testing. What does training do? What is training? Why are we doing this splitting? So whatever model you are preparing when you are training somebody, you take their exam, right? Like the way when you go to school, they teach you, then they take your exam, observe whether you have learned or not. If you've learned, then you are passed, and you can go to the industry, solve the industry problems, right? If you have not studied, right, if you failed, you go right, you go back to the same class, you study again, then do that. Exactly the same thing we are doing here. First, we are training them, then we are taking their exam, right? We're taking their exam. Like, we are essentially, what we are trying to do is, we'll split the data set into two parts, one for training, other for testing, right? And this, from the training data set, we will basically feed it to the model. We'll feed it to the model and let the model learn from this training data set. So some of the records we will feed to the algorithm. Some of them will not show to the algorithm right now. And once we have trained it, we will test whether it's working well on these records. Okay. And while splitting this data set, we want to ensure that poorer districts like this one also go to the training as well as test in the equal weightages. Okay, therefore, instead of just randomly picking, if you randomly pick the districts for training and test, the chances are that these districts will not end up in the testing data set because they are less in numbers, and testing data set, a test data set we are creating is about 20% of it. So since they are very few in the population, when we pick 20%, 25% of records, they will not turn up there. And therefore, our model will not be good at predicting these, and we will never know it because these will not appear in our testing buckets. Okay. Therefore, instead of splitting this data set just like that, we have to split it based on stratified sampling. Now you might say that why did we do it for a median income? Because we know from the history that median income is an important column. Okay. So you can also take a look at hist.correlation. So there you will see the correlation. Sorry, not this. I will show housing.correlation. Okay. So you can see these are the correlation, like it shows that which variable is correlated with who. Like longitude increases with longitude like itself. That's where, therefore it's 1. Longitude and latitude are related, but what we are trying to predict in this problem statement is the median house price. Okay, median house price. This is our target variable or label. Given all these parameters, we want to predict this. Right now, we are given this value, so we are going to feed it to our algorithm. We'll tell that this guy is a label. This is our target. Okay, and rest of it are our features. Okay. Based on these parameters, we are going to predict this for the unknown houses for which we do not know the house value. Okay, so what we are trying to do is, using correlation method, we have plotted the relationship. So you can see that which one is highly correlated. Can somebody tell me? Other than itself? Okay, this one. So you can see that, no, not this one. I'll just pick one column. This one. Okay, we go to median house value. So median house value is impacted by itself. Okay, the maximum. And I can actually just do this. Okay, median house. Right. This shows us the relationship between median house value and parameters. So it shows that, okay, the longitude is slightly dependent, like have some correlation. The bigger the value, like more positive value, means there are more correlated. Okay, so which one is the highest correlated column? Anybody? It is this one. You see that? Right? So it is this value, which is median income. Therefore, we have to be, since this particular column or this particular feature of our data set is so important because it's impacting our median house value really well. Therefore, while splitting the training and test data set, we have to make sure that all categories, people from rich areas or the areas which are rich or poor, they will all end up in the testing and training data set in a similar proportion, right? Therefore, we are creating the stratified sampling. So we are saying, yes, thank you so much. You're right. Median income is the median income is highest correlated. Okay, now we have imported something called model selection from model selection package, or you can say model selection folder of a scikit-learn. We have this module called stratified shuffle split. Okay, so now using that one, we are going to split our data set, okay, into testing or training. So here what you see is the test size. So it says that we have to divide the data set into 80-20. So test size is going to be 20%, okay, and training site is going to be 80%, right? On 80% of the data set, we are learning from the 80% data set. We will learn from the 80% of the data set, and 20% we will check with whether our model is working or not. So we are like teacher creating the exam for our model, and model will learn from the data set that we feed it, and then we'll observe in the exam whether the model has performed great or not. And once it's good, we will push it to like move it to like model will be ready for the production. Okay, so this is a very important part. Okay, right. A question is like one question is, what does it mean by negative? Negative means the more population, the less is the house prices in that area, right? That's negative correlation. If you increase population, the house value decreases. Okay. If you increase the total number of rooms, house value is increasing. If the median income in that area is increasing, the house value is also increasing. Okay. I hope that clears your idea. Now here, what we're trying to do is we are trying to split the data set. Okay. So we created a stratified training set, test set. Okay. Let's take a look at, right. I think shape is there. No. Yes. So we have splitted the data set into, right? So training set, test set, and where was our this one? Housing was the main one. Okay. Okay. So these many records, 20,000 records, some went here into training, some went here, right? So approximately 20% of these records have gone there. So this is approximately, it's not like going to split it exactly that way. Okay, it's going to be the, divide that. Now, a question is the correlation is required to pick up the right column, correct? And stratification is avoid bias. That's correct. So we are, first of all, using correlation, we figured out that this column is important, and above, by looking at the histogram of this particular column, we saw that there is a huge distribution problem. There are very few people in this category, right? Therefore, we need to do stratified sampling. So whenever you see that a column which is very important based on our correlation, if the column has the value is skewed, like so many values are in one particular category, other one there's very few, in those cases always use stratified sampling. Otherwise you use some like a straight random sampling. Okay, so because we need to divide the data into testing and training and so on, right? So sometimes what we usually do is we start without stratified sampling. We just basically split random sampling, observe how well is our model performing, and then go back and fine tune it by doing the stratified sampling. Perfect. So that's pretty much. Now we are done with it. We can drop the column. Okay. So now we are done with it. We created a column called categorical variable, because when we are using stratified sampling, we have to tell which column is the basis for stratification. Stratification is creating stratas. And this method, what it does is, stratified sampling, what it does is, from each strata, it will pick 20% of the record and put them in testing data set. Okay. That's what is happening here. Okay, so study, you can just take a look at like help and write if you want to at any point of time. You can just press A. So notebook works in like a quick thing for all of you, those who are going to use notebook a lot. So it has two modes. One is command mode, another is editing mode. Right now I'm in command mode. Editing mode, because this cursor you see here, and when I escape, it goes into the command mode. Okay, click it or press enter, you get into editing mode. Press escape, command mode. In command mode, the various shortcut keys you can take a look at here and figure out like all the shortcut keys. So to insert a row, to insert this or that. Okay, a random state is essentially to ensure that a very quick thing for all of you, right? So usually while you are training and building your model, what happens is every time you split the data set, random records end up. Okay, random records end up in test data set, and you are not able to reproduce the result, right? You basically saw, oh, this was giving me this much performance, and again you did it. This time you got different performance. Therefore, it's better that random split is not truly random. It is a function of the random state. If you change the random state, it will be different. Otherwise, every time, if the random state is same, test data set will have the same record, training data set will have same records. Okay, so make sure that you use random states in your data set. And of course, if the data set changes, then even if random state is same, it'll end up, right? Same record might end up at different places, but that's okay for now. But there are ways to handle it by creating some kind of key based on the ID of the record. Okay, so that you ensure that the values are ending up everywhere. Okay, so never mind. So we are not going to go into that right now. We'll just drop the column that we had done earlier. From both training and test data set, this is our training data set that we have created just now. This is our test data set. And from both of them, we have deleted this column. Okay, so this is essentially, we are saying, instead of saying this dot drop and this dot drop, we are just using a clever for loop. Okay, though it doesn't make sense because in both the cases it could have been just 2 lines. Okay, and never mind. So we got okay, it's already deleted, so running it twice will not work out. Okay, and let me just clear it, like I'm just commenting it so that it doesn't run all the time. Okay, so perfect. Now moving ahead, submit it. I got 100 more points. Let's move to the next one. So stratified split and train test split, there is a slight difference between the two. Usually we use train test split, but that one doesn't have the stratified, like picking the records based on the particular strata. This is stratified sampling split is similar to the normal splitting way, randomly selecting 20% of the dataset or whatever percentage of the dataset. Just the difference is the category. We are passing it. This is our categorical column based on which it has created the strata. And then from each strata or each bucket, it's going to pick 20% record, put them in testing, 80% record, put them in training. Okay. Now, all right, so what we're going to do is we are just going to replace housing with the new copy of stratified training set. Okay. This is for just a convenience so that we basically just focus on the correct variable. Okay, so yeah, so this is what we have done. We have to make the copy of the training set, replace it with housing. Don't get confused because earlier housing represented the whole data set. Now after this step, housing only represents 80% of the data set, which is there. Okay, the training set. Now let's do a scatter plot using Matplotlib using as follows. Okay, let's see. Will it give an error? Okay, there's nothing much to do for me here. Okay. So here you see that what we have done is we are trying to visualize it. And in this folder, there is the map of California, which we have put as the background. And I mean, a better thing would be to learn the various arguments of plot. There is a lots of things. This is a scatter plot. All the dots are scattered. There's X is longitude, Y is latitude. This is the column selection. And then there is a figure size. And then there is, right? There is a, right? Size of each dot is based on how much population is it. And color of this one is based on house value, right? The red means too much value, blue means a very low value. Okay, so you can see that here the blue means these are the areas where the house value is lower. These are the areas where the house value is higher. So that's the beauty of plotting it using the scatter plot that we were able to see nicely. Now notice that there is a C here, right? And there is this. Do you see any correlation between beachside houses and others? Lots of houses near to the sea have very high prices. Okay, the houses which are away have different thing. Now the important part that I'm trying to say is that although it makes sense, but also look at, let's say, these houses, right? They are not on the beach, but away from the beach, still their value is red. Okay, so but you can see that the areas which is basically the population wise, there's some kind of correlation over here. All right, so I hope this this is basically part of visual analytics. You should try to plot it to your convenience based on the problem statement. Try to plot it. Okay, so this is how we have tried to plot it. Okay, so take a look at how right, how you can convert a problem statement into this. Okay, so that's pretty much. All right, let's take a 2 minutes break. We'll be back in 2 minutes. Okay, let's take a 2 minutes break. We'll be back in 2 minutes. And yeah, let's take a 2 minutes break, everyone. All right, I'm back. Okay, great. So far, we are through with 7 out of 16 steps. Okay. Now, we are still analyzing our data, and we have divided the data into training and test set. Okay. Again, a quick recap. What we have done. One, imported libraries. Imported the libraries, loaded the data, visualized our data, splitted the data based on a stratified sampling into training and test. Okay. So after we have divided the data into training and test, we are basically focusing on our training data set, observing how is the data, distributed on the plot. Okay. Our question is that we have come to the concept of stratified shuffle split when we see biasness in our histogram. That's right. Specifically biasness in a column which is important, which is highly correlated to the output. Okay. Yes. So once we have done that, now we are, we have split it. Now split the training and test. Now we have training. Now let's focus on the training data set. Try to understand its behavior, how it's there, and so on. So now you have the clear picture that this is the value of the houses in the color. Color represents the value of the houses, and you can see that the circle size represents the population. You can see this one has high population, and wherever there is a higher population, there seems to be the lesser price. Okay, and so on. So you can see that there is some kind of you can visualize this. This is longitude, latitude, just like on the map. So this is in the background we have put the map. So now it'll make a lot of sense to you. Okay. Now, perfect. Let's move ahead. So now we basically will create a correlation matrix to see correlation, though I had already done it. So the correlation coefficient is a statistical measure of the strength of a relationship between the relative movement of two variables. Okay. All right. So there is some people asking to download the PDF for this one. My point is that what's the point of downloading PDF for this one? Okay, I do not understand this. Okay, it's not something that you could print it and submit as a project. No, it is something that you have to do it here. Okay, so follow the step on the left hand side, follow it on the right hand side, like read the steps, do it in the lab, and once you are done with the project, based on the understanding of what is it here, you prepare your project report if you have to submit it somewhere. Okay, so the most important part that I'm trying to say is once you focus here, then everything will be okay. Even if we give you the PDF of this one, it's not going to be of any use to you. Okay, I hope like it makes sense to you, Mohammed. All right, Tathagat, I answered your question. Did I make sense to you? Perfect. Now let's move ahead to the next step. So we are trying to see the correlation. Also, we are also creating 3 more features. Okay. Now you might ask, like, why are we creating these 3 more features? Okay. We just, we discussed with people in the housing industry. They have figured out that, oh, there must be some correlation between rooms per household. Okay. So here we are creating those 3 parameters, these 3 columns, or you can say that we just got the hunch about this problem. Okay, if we divide the room by households, per household how many rooms are there on an average in that area, and bedrooms per room, and so on. So let's try these 3 columns, okay, and see which ones are more correlated. So we added, you can see this is how you add a column to an existing data set. Okay, and let's take a look at the correlation matrix. All right. So let's take a look at the correlation matrix, specifically this one. All right, so you can see now the correlation. Median housing income has the highest correlation. You see that? Room, because we are finding this one will be anyway one, because the variable itself, a particular feature or characteristic, has the same like its value increases with itself. Therefore, the correlation here is going to be always one. This one is 68.68. This one is 0.146. This one is 0.135. Now you see that we got these total. If you see these, you can say these couple of columns have the very high correlation. Specifically, these rooms per household has got the second highest. Okay. So we were lucky that we created these columns, and out of this one seems to yield better. Okay. And yeah, we are just lucky here and created this one. Now let's try to plot it. Okay. I think it will take some time. Yes. Now you see that we are plotting the correlation matrix, or you can say we are plotting this scatter matrix of median housing value, median income, total rooms, and this against right, this against these. Okay. So out of this, what matters to us? Median income column, sorry, median house value column. So you can see this plot, what it shows is that how median house value changes with the other column. Okay. So this one we can ignore because it's plotting against each other. When we do that, it essentially plots the histogram. So it just shows, because it doesn't make sense to plot a chart of it itself against itself. Okay. It'll be like a straight line, 45 degrees. Now, here you can see that median income, as median income grows, the median house value seems to grow. You see that? It's a positive correlation. Okay. And you can see here that as total rooms grow, the house value seems to kind of grow, but not very clear, right? So always the numbers, this value is way more better than this kind of matrix. But this is good to plot. This is to show that this is called positive correlation. Okay. As you can see the cloud, it's like slanted upwards. Okay. As the median income is increasing, the house value is also increasing, correct? And now you can also get a little bit more ideas about the housing data set. Okay, so this is called the the visual analytics or data exploration to get the feel of what it is. Okay, about every machine learning project. Let's move ahead. Okay, so now we have to fill the missing data. Missing data is in terms of, some of the values, as we saw earlier, were missing, and there were a number of values were missing. We saw it earlier. Okay, for particular column. So there we have to, delete the data set. Okay. So we will revert to a clean training set that right we got after we use stratified sampling, and drop the median house value, since it is the label that we are predicting, correct? So since this is the value we are predicting, so we can remove that column from the training like set and put it in separately in label. Okay, so we are dropping it from here because this is our label. This is the target variable, because when we have to feed it to algorithm, we have to feed it separate, this column separately. It should not be part of the features. Okay. So all right, we are saying that here we have to create the housing label. Okay, so all right. So I mean, of course, these are very quick and easy to solve problems, but the purpose is that you should understand what's going on here. From the after stratified sampling, what the data set we got, from that one we are removing this. Okay, please note that when we drop it, it does not really delete from here. The new data set that it returns will not have this column. Okay, and here similarly, when we are basically accessing this particular column, it is still there. It did not get deleted from here. So this one will not have this column. This one will have only this column. Okay, so let's run it. So we got two frames. One is housing and housing labels. Housing label only have the value of this one because this is our target variable. Based on this data set, we want to predict this. Okay, and we want to train the model, telling the model that, hey, this is our input data, this is our label, learn from it, and then we will feed you the test data set to check if you are doing good or bad. Okay. Now we will impute the missing values. Now we will impute the missing values. Okay, import simple imputer class. Okay, from scikit-learn dot impute. Okay, it worked. Now let me from this we imported this. Now for the missing values, we will consider. It'll be ending in 20 minutes. Okay, and now consider this. But whenever it ends, you will be in a good shape to complete everything by yourself. And so it says that the strategy should be median. So we are saying that, okay, imputer, what it means. Okay, let me just give you a very quick preview. So what is imputer? Let's say in your data set, some of the values are null. For some of the, while taking readings, we could not get those column values, so we left those null, right? In such cases, what to do in order to make it, feedable to the algorithm, because algorithm wants some value to be there, right? Therefore, what we do is we either delete the column, we delete the row, or we basically fill this value with zeros, fill this value with average, fill this value with mean. So here we are choosing to be median, to fill the value with median, though there are many strategies with which you fill this, missing values. In one of the cases, I saw that people were using a decision tree, another machine learning model, to fill this particular cell. Okay, but okay, so here you see that we are basically, for the whole column, we calculated the median value and we are putting that median value in here. Okay, so we created our imputer class. We can just write. Also, one more thing we want to show you, for all of these columns, we are going to fill the missing values with the imputer, the median of the whole column. And what we are going to do is we're going to drop the categorical attributes. Okay, so we are saying that from the housing, we are only picking the numerical attributes, and right, and we're basically picking that. And now, using imputer, we are preparing this, preparing the median values of the all columns. Okay, and okay, now we got here. Now, after we have done that, okay, so please pay attention here. So we are saying imputer transform, okay, and we are creating the data set from it. Okay, so what all we have done? Number one, we have splitted the data set into training test. From the training set, we have basically removed the categorical variable, as well as we have removed the label. We have kept it separate. And in the numerical data set, we are filling the value with the median value. Okay, that's what we are trying to do here. So this one is basically, this is our data set. Also, we have added a couple of more columns there. Okay, so this is our data set. Okay, this is our data set. See that? Now, moving ahead, all right. So these are the various steps you have to do in most of the projects. And most of the strategy that we are following in this particular project would also be there in most of the other projects. Okay. And so we here basically now is the time that we are going to handle the categorical variables. So here we are defining the categorical variable. Okay. All right, those who came late, they basically can find this project if you go to guided project and select machine learning. Okay, select machine learning and remove this. Just search for California. Okay, yeah, this one. Okay, so yeah, you can just use that one, and that's pretty much. So you can also explore more courses and more projects and try to doing that. So here we created the basically the column that we deleted there. We are extracting here and going to convert that into numeric by using the method. So here, let's just take a look at this particular column that we are worried about, because that one has some strings and text. Can we take a look at that one using head? We can take a look at that. So you can see it has like 1H, this, that. Okay. Therefore, now is the time that we convert it into one hot encoding. One hot encoding essentially converts this into those many columns, right? It has, let's say, it has say to 20 values, unique values, so it'll create 20 columns. Okay, 20 columns, and it'll put a tick mark in each, like 1 wherever that value is matching, otherwise it'll put the 0 there. Okay, so once we have done that, we will just go over here. All right, and all right, let me scroll down. Okay, so this is basically what we are trying to do is all right, here. Okay, don't mindlessly copy it, just study it, try to understand what's going on here. Here we are creating an instance of one hot encoder, which will, okay, so yeah, so somebody's asking what's going on, guys. Okay, let me give you a context again. Do not freak out. So what is it that we are trying to do is we are trying to learn from historical California real estate data in order to build a model which will be able to predict the house pricing. And this is essentially like teaching machines to learn from the data. All right. And what we have done, we've splitted the data, we loaded the data, we splitted the data, we observed and we plotted the data. And then now we are converting the non-numeric data into numeric data, because numeric data, you won't be able to, numeric data, you can feed the algorithm the numeric data and algorithm can figure it out from that. It can learn because algorithm wants the data to be numbers. Okay. Therefore, we have to convert like categorical variables such as high, low, those kind of variables into numbers. Like for example, this one, we're going to convert it into columns. Okay, so there will be one column called 1H less than 1 R from ocean. That is one column. Near ocean, that's going to be second column, and we'll put one where instead of this value, wherever that column is. So that's what one hot encoder does for us. Okay, there we go. So now it'll make more sense to you. Let me just show you, right? All right. No, okay, let's just do this. All right, why does it not show me? Okay, so it is essentially done that. Okay. All right. So if I just say, give me first 10 records, will it work? It's not printing it. Okay, let's just see if the print is working with it. Okay, so you can see that it has created a kind of a matrix whereby it has created the categories, like for this column, this value is this much, for this column, this value is this much. It basically, right, converting it into multiple columns and putting a tick mark in them so that we are able to, we are able to do, convert it into numbers. If there are 100 such values, it'll create 100 such columns against, as in unique values. 100 unique values, you'll get 100 columns. So take a look at what is one hot encoding and try to understand what exactly is going on there. Okay, so now coming back to what we are trying to explain is that this is one step where we convert the non-numeric data or categorical data into this. Sometimes the text, it is text, like for example, comments from the users or feedback from the users. What do we do in those cases? We convert the text into word embedding that you study in the natural language processing chapter. And basically these machine learning models, pre-trained models like GPT-3 or something, they convert the text into numbers, and that numbers you can feed to your model. Okay. All right, so there we go. And basically we can do here, right? You can convert it into 2 array and that'll make more sense. Okay, let me see what's going on here. All right, never mind. So you can see that it has converted it into 1, 2, 3, 4, 5 columns, right? For the first one, this is the value. For the second one, again, same value, first column. And for the third one, this one, this is the value. So you can imagine that this one is less than 1 hour from ocean. And this one seems to be near ocean. And this one seems to be inland. This one seems to be inland, and so on. So this gives you a clear picture on what's going on, right? So one column got converted into how many? 5 columns, right? And against each value, basically it's marked as 1. And since there is only one value here for each category, therefore only one value is on, rest are off. Okay, only one value is 1, rest is 0, correct? So this is essentially creating, converting, this is how you convert categorical data into numerical data. Okay, so let's move ahead. All right. Okay, so a question from Robo Dream is, what is the required skills to move machine learning? Move to machine learning. Don't worry about the required skill. Follow this tutorial, follow this project in Explore projects. Trust me, you'll get most of the ideas. Okay, and just attend to a couple of our video lectures. You will get a fair picture about machine learning. I do not think that you require too much of mathematical foundation. If you are okay with the basics of basics of maths, that should be good enough. Okay, but again, if you are really good at maths, then you may invent an algorithm. You may come up with new ideas. If you are okayish with math, you can do the machine learning, what we are doing it here. And what we are studying right now is something that anybody with a bit of IT background or programming background, they will all be able to do it. Okay, if you are not from programming background, so I would strongly recommend going through, say, Python project in our course, and that will help you. All right. Can we use simple imputer after we have converted the categorical data into numerical data? Because, right. Thank you, Rutvik. That's also a good idea. We can do that as well. What is the required skill to move to? Okay, I think I answered that question. What's the libraries that we have used so far? Please enlist some of them. So we have used NumPy, Pandas. You can take a look at, just search in this notebook as you're proceeding, right? Just look at import, okay? So we are using scikit-learn. We are using the scikit-learn, NumPy, Pandas, Matplotlib. Those are the main libraries that we have used. Okay. And yes. All right. Is this the only encode we convert string to numeric? Here, since it's a categorical variable, we are using the one hot encoder. But in the real life, sometimes the data is text and like comments from the users. There we use the NLP and we use the models like GPT-3 and other machine learning models. Okay, for deep learning models for language processing. All right. So. Right. Yes, that's right. Thank you, Ankit. That's correct. So the algorithm understands the numbers, not the objects. So features, right? Okay, right. So we use the feature selection or not. If use, what did we use? We basically using the pandas that we are doing, right? We also did correlation and we observed which columns are important, which are not. Okay, we have dropped a categorical column then, right? We will basically, yeah, that's right. So we have dropped the categorical column, converted it, and then we join it. But you can also do, there are other ways to do it. Question is, no one is a multitasker here, can't listen and track at the same time. Okay, so I would say that focus here, what I'm talking about, and you can do this project probably just after this webinar ends. Okay. A question is also if we convert categorical data to numerical with separate column, then the test data also we need to do this. Correct. Thank you so much. Yes, we have to do the same thing. In the website, the chatbot function behind the logic based on machine learning. Yes, this is very resourceful. Much love from Ghana. Great. I'm really happy that you are, from all over the world are here and asking questions. I'm really happy to have such a wider audience. And I hope you all will learn something today. And do not stop here. Explore all the projects at CloudxLab and try all of them. Okay. Yes. Okay. A question from Eric is very, very good question. So how many years would I need before I can build and train models without tutorials? I would say there's just 2 projects. Just do 2 projects and you will be up and running. Okay. And yeah. So just 2 projects, one probably this one and so on. Hi, I'm happy to have people from Kashmir as well. Wonderful. Wonderful. And I hope that, these tutorials, I can bet if you pay attention and work with me, your life will change forever. Okay. You just focus on project, try to do it, and you will have, lots of ideas about machine learning, and probably you do better than everybody in the field. All right, so let's focus on it. And most of my learners in past have done pretty good job in their respective domains. All right. All right, I'm not able to understand the question, Ankit. Never mind. So what we're trying to do is we are trying to build basically pipeline, which will do whatever we did just now automatically. Somebody has correctly asked that wouldn't we have to do the same thing what we are doing for training data to test data? So better than that is basically create a class which does automatic. So whatever we did above, here we are doing it automatically using this particular class. And therefore we always, as a part of machine learning pipeline, always convert all the translations, whatever logic you're putting into these what do you call transformers, or you can say estimators, so that you just do transform or fit, and it basically your class can be used. So this way your pipeline will be really clean. Instead of doing stepwise the way I'm doing right now, you will find it nice. Okay. All right. Okay. Ankit, now I got your question. That maybe 30 years. No, it's not that big. It's not that big a deal, but I would say that it'll take you some time. Okay. It took me 10 years to learn programming. Okay, I'll not lie, and that all the books that say that 24 hours in 24 hours you can learn coding, no, you can't. Okay, even like it's like guitar. When you want to play guitar, really good one, you just spend 10 years in it. Okay, but you can get to play like a decent stuff in a couple of years. Okay, so explore a lot. Explore in technology, in IT, in software. There's lots of scope, lots of dimensions. Explore and you'll find your ways. Yeah. Okay, so let me move on. I'll wanted to keep it like right, a clean one. So whatever we did, we are just creating pipeline right now of the steps so that we can automate that stuff. Okay, and you can see that once we have defined this pipeline of adding this, doing imputing and all that, now we can just call our pipeline like this, and we are all set. Okay, so we can say fit underscore transform. We created our own pipeline called full pipeline here. Okay, that has adding of this column, that column, and so on. Right now we have created our pipeline. We are all happy. Let's move ahead. Okay, so whatever steps we were doing earlier, like filling the missing values, converting into one hot encoding, we were also remove that categorical variable, added it again, and so on. All of that, we created a pipeline. Now we are all happy so that we can just call it like fit transform on testing data, training data, anywhere we can just call it there. Right now we are just passing it the training data. Afterwards, we'll passing the testing data set. Okay, so here we are at the 12th step. So it's pretty simple. Now the time that we are really prepared doing the training. So housing prepared is our column, is our data set which contains the data, okay, which contains the data in the number form. Okay, so you can see it's all numbers. Every row that we saw earlier has been converted in numbers. Now is the time that we feed it to the algorithm. Okay, so first of all, let's import our algorithm. One of the algorithms is decision trees. Okay, the decision tree is essentially going to split the data into kind of internal buckets and estimate it from the nearest one from there. Okay, but if you want to learn about decision tree, you take a look at any of the courses we have gone into deep. But trust me, it's not really needed right now. You all need to know is that decision tree is one of the algorithm, or you can say one of the models that does the job. Okay. So here we go. We have trained the model. All right, so it's saying that, okay, let's import the mean square error. What is mean square error? We are trying to see how well is our model performing just by observing how much it is differing from the target, right? And how do you do that? You ask the model that what is the value of the house for these parameters. Then the model will say, okay, this much. And we compare it with the actual one, subtract it, and square it and keep it aside. Then we do it for all the values, and then we compute the average of these. That becomes the mean squared error. That tells like more mean squared error means the model is performing bad. The less mean squared error is the model is performing great. But there is one case where if the mean squared error is very low, there could be one more possibility that model has memorized everything. Okay. So now we can test our model if it is okay. So let's just follow this. All right. All right. So here you can see. So it says true, mean square error is 0. You know why is it 0? Because it has memorized everything. It has just memorized everything because it, right? It just memorized everything. And we are testing, we are checking the value on the training data set itself, right? Question is, are we creating service endpoint, right? Not in this project, but in the another project, a Flask-based project. Just search for Flask in Explore Explore courses. You'll find a couple of projects which basically create the endpoints. Okay, there you will learn how to create the service endpoint, because these models are hosted as a service. So we'll take 10 more minutes and then we'll move ahead. And there was one question regarding Indian cities. Thank you, Rutvik, to answer that question, that you can take a look at the Kaggle and start. Yes. Why we are squaring error? Is it like doubling? No, it's squaring in the sense like for one record, we compute the delta, square it, then we take another record, compute the error, then we take third record, compute the error, and square it and sum up. Because if you do not square it, these values could cancel out each other. One is positive, other is negative, and they could cancel. And also, individual error is amplified when we are doing the square, okay, instead of being ignored. All right, so here we go. We are going to use a different model now. Okay, we are going to use a different model called random forest regression. Okay, and let's see how it goes. Okay. All right, so we are going to use, what do we use here? Anybody? We are going to use here fit. Fit means learn from this data. So notice this code very closely. This is the name of the algorithm class. We are asking this to create an instance of it. Okay, so this is going to be our model. Okay, and here we are providing called hyperparameters. Hyperparameters are specific to the algorithm. You can find out about algorithm and figure out what are the hyperparameters. So random forest is essentially like it internally has many decision trees, like 100 decision tree we are asking. A random state is to ensure that every time we run it, we get the reproducible results. And here we are saying model dot fit, and we are giving what all we are giving? The features and the label. What is the label? Label is the median house value, and these are the features like how many rooms are there, where is it located, and so on. Okay, now all right, now once we do that, we can predict using this. Okay, we can predict using this. So let me just say predict. All right. Now you see that this one has got error, right? Let's say, right here earlier it was error was 0 because it memorized the data set. Okay. All right. Okay, a question is, please organize a session on AI also. Actually, we keep on organizing the session on machine learning AI very frequently. My request will be that, right, those are very theoretical sessions. I want it to be like very practical so that everybody does something with me. Okay, and like at your own pace, go to Explore courses, start doing these projects. These projects are all free. There's nothing, we are not charging anything for it. Okay, so the only thing you'll need is the lab. So you can just take a free subscription, refer your friends, or you can buy a lab. That'll be good for us also, right? Right, we have to have the team who can do that, as well as feel free to create your own projects here. You can create if you are a teacher, you're a professor, you can create your own, such kind of projects, test along with the test cases very easily at your own pace. Okay. So now we are going to do something called k-fold training. Instead of just manually doing this, we are going to split the data into folds, right? Like here, this is what we're going to do is we break the data set into 5 parts, training data set. We train it on 4 parts, test it on 1. Then again, we train it on this, test it on this, and like that. We will do that. We will do that for the data set and observe whether the model is performing good or not. Why are we doing that? We want to find out which of the model is doing the best. Okay, and how do we do that? We don't want to look at the test data set that we have kept aside, because we want to compare these models against each other. So what we'll do is, whatever training set we had, we will split it into parts. Okay, one of the parts we will keep it aside, and for the remaining parts we will do the training. Then we'll, like that, we'll have first model trained on this one and tested on this one, then second model trained on first to tested on this one, and remaining parts on which it will be trained, and like that. So this way we will basically figure out which model is good or bad. But before that, let's create a display function so that we can quickly compare. We can quickly compare how is the model performing. Okay, take a look at what each function is doing. Here we are giving scores, and it's nicely printing those scores. One of the scores is the mean. Mean is like what is the mean error of all the runs, because if we are splitting into 5 parts, it will run 5 times. It will train 5 parallel models and try to see what's the average error. Okay, and like that. So this is called the cross-validation technique. Okay, this is called cross-validation technique, by which we basically compare the different models and test which model is good for our data set. Okay, so instead of being judgmental about, like in this scenario we use this model, instead of doing that, we usually what we do is we pick up the model which can run on this data set and then see which one is performing great by using the k-folds, right? The cross-validation. Okay, now we've defined this method. Now let's move on to the next one. All right. Okay, so cross-val score is a function from the model selection package of scikit-learn, which we are going to use in order to figure out which one is better. Okay, so here we are comparing this model. We are calling this model through the cross-validation. This model will be trained 5 times parallelly, and basically we will see how well they are doing. Okay, so let's just import it again and run it. Now, similarly, we will also train another model called forest regression. So this is decision tree, this is forest, and then we observe how well they're doing. Okay. Earlier when we ran, this one was performing very great because it was training. We were training and testing on the same data set, right? Now you can see the error. The error is fairly high now. Okay. Now we'll see the error of this forest regression. Okay, it's going to run 5 times, which means 500 decision trees will be trained internally, and then it'll give the results. And that's why it takes time. Not 500, it's going to be 10, right? 10 into 100, 1,000 decision trees are getting trained internally. Here, this is one, like this is 10 decision tree. This parameter says that how many folds are going to do that. Like here, it was 5 folds. So first we do train on this way, this way, this way, this way. And here we are seeing cross-validation is 10. Therefore, we are going to get that results. Okay, so let it finish. It's going to take a bit of time. In your case, to make it more efficient, you can decrease the number of estimators to 50 and cross-validation to probably 5. It'll make it extremely fast. All right, it might take a bit of time. Let it complete. In the meantime, you can ask questions and I can answer. So what is it that we are trying to do? This is the training. Training times are usually very high. Therefore, it is important. It is important that we basically take a bit of time for training. Okay, usually training is run on high-end computers. Here we have a shared machine in the lab. Therefore, it's going to take a bit of time. Okay, and usually what you can do is you can reduce the CV to 5 or something. Okay. Why the CV value, the cross-validation value is 10? Cross-validation is 10. It's just a practice that we have been following. Okay, 10 means that we are going to run 10 trainings in the background. 10% of data will be used for testing each time, and remaining 90% data will be used for training. Okay. So question is here in this case, right? Like forest regression, whenever we are training it internally, it is training 100 models internally. Okay, because that's what is random forest. Like it has forest has trees, so it has 100 trees. It's like that. Okay, and cross validation of 10 means there'll be you know 1,000 times training that will happen, and that's why it's taking a bit of time. Okay. Okay. I think we'll reduce it. Because I'll correct this test case also, because it's going to take a lot of time for training and the kernel might disconnect. Okay. Ah, man. Let me just see if it passes. No, it won't pass because it's just busy. The kernel busy. Okay. Yes, till now we have not used the test data. That's right. 2 algorithms means we are creating 2 models. That's one of the questions. So right now we are using 2 algorithms, 2 models basically. Internally, one of the models is essentially random forest. So it has hundreds of trees and so on. Okay. So it's going to take a bit of time. So let's just wait for some time. Let's see how it goes. Of course, this video will be available for everybody. Okay. Yes, check the documentation of decision tree regression. Yes, please. That will be good and it'll help you. Okay. Yes. And a question is, if you want to have fun trying teach your computer to recognize child and migrant painting as the plane or a tree. Yes. Okay. All right. Now we have finished the training. Now let's just try again. Okay. So it took some time, but it gave the results. All right. We passed to the next step. Okay. A question is, in real world, what a data scientist, AI engineer, machine learning engineer, deep learning engineer can do? The roles, please conduct. Of course, I will conduct the session. Okay. But I would suggest that in every role, in all of these roles, what we are learning today is going to be common. Okay. All right. Now, the same thing what we have done earlier, we are going to do here. Okay. We are going to do here. Now you can see one thing I want to show you, all of you. Now look at this course. Okay. Decision tree is giving this kind of error, and like mean error is this much and standard deviation is this much. In case of the random forest, the mean error is 50,000 and standard deviation is this. Standard deviation as in how much variance is the error. Okay. So which one is better? The one that has lesser mean error and lesser deviation. Okay. Therefore, random forest is way better than the decision tree. Okay. All right. So the thing is that the way we check which algorithm is better is by checking their performance on unseen data. Okay. And cross-validation helps us doing that. So, all right. Now moving ahead here, let's just, I think I'll just finish in a couple of more minutes and be with me. I know that you basically came leaving your work. So, okay. So in the last question is that, okay, after comparing, similarly, you will compare it with linear regression, SVM, linear, decision tree, XGBoost. There are like many algorithms. And as an engineer, what you should ideally do is, what we are doing here for one or two algorithms, you basically do it for your own. Okay. Now, basically, what we have done is we've figured out that this random forest is doing good now. Okay. Now we take this algorithm, fine tune it. How do you fine tune? This random forest was taking many parameters here, right? Number of estimators, random state. So what we'll do is we'll start trying various values for these parameters. Okay. We do not know. We are like blind man. We are trying all hyperparameters. Okay, and just trying to see which one does perform better. Okay, and how do we do that? Using either our own for loop. We can write our own for loop and train it multiple times for different parameters, or we can just use the grid search. Grid search exactly does that. Okay, grid search exactly does that. And there we go. All right, so great. I mean, this session was very fruitful to all of us. Okay. All right, so here it's going to take some bit of time. Here only we are using random forest, okay, to train this model and different parameters. Here we are saying that for n underscore estimators, try these values. For this particular parameter, try these values. So it's going to try 12 such permutations, right? 4 into 3 plus is going to try next time is going to try these values, which is going to be 3 into 2 plus into 1, which is going to 6. So total 18 permutations it's going to try of these parameters and observe which permutation is giving best results. Okay, so that's what is happening right now. And once we are done with it, we can save this, like we can export these parameters somewhere. Okay, we can export these parameters somewhere and be happy about that. Okay. All right, it is now trained, and you can now see that. All right, so you can see that these are the best parameters that we figured out by using this whole grid search. Is nothing but you can think of it like we are doing the for loops over and over again. Now here is the important part. So you can see that for all of these various permutations of the features, right, like max features and various permutations, we have called this algorithm multiple times, and these were the errors. Okay, so from this we figured out that this is the best way to do it. Okay, that is the best way to do it. Now let's move ahead. Let's just test it. Okay. All right, now so all right, let me just pick it as is. Okay, this is our best estimator based on the previous grid search. Now what we're trying to do is we are trying to test it on the test data set. Okay. Okay, so it says, now let's drop the label from xtest and that our model will be predicted. Save the attributes in the variable called x underscore test and save the labels in another variable called y underscore test. Okay, so we do that. So now we are done with training. Okay, now we are moving ahead to checking whether this model is performing great or how much it's performing on the test data set. This test data set we had kept aside in the beginning so that we do not look at the data set. Okay. All right, let's do that. All the transformation, that pipeline where we created earlier, we are just calling the pipeline now. Okay, and we got the clean data set now. And these are the final predictions on the test data sets. Okay, and let's see what happened here. Final model. Where did the final model go? Did I make mistake here? Oh, I'm supposed to keep it in the final model here. Okay. All right. Now you can see that. Good. So now we can take a look at the the performance. Okay. So this is the final the final value of the error. So you can see that after all of these permutations, we are able to, like, our model has performed really well. The total root mean square value or mean square error, right? This root mean square error is pretty low, okay? Pretty low. And that's a very important part to know this, okay? So essentially what we are talking about is, let me just see what is happening here. Okay, so the root mean square error is this much overall, and I think that, yeah, that is the mean square error, and then we did the square root of it. Okay, so this is our overall root mean square error. So you can see that this is basically it. And those who are wondering, where is our model? Okay, let me just show you where is our model. This was the final model, right? So if you take a look at this model, this model is our, these are the hyperparameters, right? Okay, now you can, all right. Also with this, you can take a look at feature importances. Okay, these are the various feature importances. Okay, so some of them are high, these are the real, after training, this is what it has figured out, which feature is important, which feature is not important. Okay, so you can, while you are preparing your presentation, you are presenting your algorithm or model to somebody, or your boss or your customer, you have to take a look at the model and you have to present it there, right? If you are trying to ship it to production, what you will do, you will persist this model, final model, to a file and then load it in the production. A model is nothing but bunch of numbers, okay? A model is nothing but bunch of numbers. The whole brain that we call, whether it's neural network, whether it's anything, it's just bunch of numbers, okay? You save it in a file, take it to production, load it there and do that, all right? Sometimes you create a service out of this so that whenever somebody's asking, let's say this is a website running and this model is there waiting for the user to ask a question and it responds. Okay, so there are many ways to deploy a model. One is like a service, other is like a script, other is you are not deploying it, you are using it for inference so that you can, teach people or explain or make them understand which columns are important, which data is important, how the data is distributed, and so on. So there are quite a few use cases of this. This helps us understand the data better, understand the behavior of the user better, and that's about it. All right. So I hope this was useful for all of you. Okay. Wonderful. So good. I got quite a good points from it. Okay. Wonderful. All right. I think that's pretty much for today. We are done with it. So there were 16 steps, pretty big steps. Now, once you are done with it, you can download it as PDF. Okay. Or you can create your own project and then do that. All right, it opened in new folder. Oh, it did not work. Never mind. Why it did not work? I have no clue. All right, so we'll have to see this. Now next, can I not try it like download it Python or, well, by the way, this file is actually saved in your home drive. Okay, so if you go into say CloudxLab, all right, and say my lab, and you click on Jupyter. Okay, here Jupyter. Okay, so the file that I'm working on is inside somewhere in my home directory. This one, CloudxLab Jupyter Notebook. Okay, for each of the playlists, it creates this one. Okay, this one, right? This is the file, this is the notebook that is still running. So you can select it. You can also say download it. Somebody was asking how to download it. You can do that, okay? And you can also view it, and like you can use FTP to download it from your Jupyter Notebooks, okay? Or you can use all those techniques. Is there a way to download it? All right. You can use SSH, or you can use various things. All right, so I hope this was useful, and I would strongly recommend all of you, I would strongly recommend all of you try to do it by yourself. Go to explore courses, select on guided projects, and go through the project that you would really like to do. And today's project would be under, like if you search for California, it'll come out. Those who are asking about right, deploying models and all, I would strongly suggest, if you are a full stack engineer or anybody who wants to learn how to deploy a model in production, this series on Flask and this is really useful to everybody. Okay, so, and this one is like one of the very important projects. If you are a engineer who wants to learn how to scale a machine learning model, this would be the very good example. Okay, so I would strongly recommend trying out these projects. These projects are very useful to all of you, and make sure that you do it by yourself. Okay, and do not watch this video until you do it by yourself. Okay. A question from Krishna is how is it different from using AutoML? AutoML is a black box. It doesn't help you learn anything. Therefore, my strong suggestion will be learn the process, then AutoML will not look like magic to you. Otherwise, you will develop a kind of a fear, a kind of a black box. And the moment you use AutoML, if it's not performing good on your data set, you will have no way to fine tune it, because you do not know about your data set. So there are many situations where you would like to know about your data set. All right. So I hope this session was useful for all. I know that this was very practical, very hands-on session. It was not at all theory, but that's how I wanted this to be. I wanted it to be something very useful to all the people. Thank you, everybody. I know that we went to 30 minutes beyond the time, but I hope this is useful to you. A question is how to deploy a model in a mobile app. I would say that learn how to launch a service, and then you look at the. There are two answers to it. Very important one. If anybody wants to stay back, the question is how to deploy a model in a mobile app. So there are two ways to it. One is using TensorFlow Lite or other libraries. Other is consider it, launch it like a Flask service, like launch it like a service. Okay, and from the mobile app, just call this service from the remote. Okay, that should do the job, because on mobile app the problem is the processing and loading the models. Loading the models sometimes could take more memory, and therefore the OS can kill it. And sometimes running the model takes a lot of battery, and therefore people prefer it launching at a service. But if you want to, it is mandatory that you have to run it on mobile, then there are a couple of ways. Number one, first way is using the TensorFlow Lite. Second is using any of the Java-based models, and you can use that. Okay, so I hope this was useful to you, and have a great day. Any video training for these project? Yes, I'll be doing that as we go forward. I'll be picking up one project and would do that similar to today. All right, so stay tuned, share with your friends the channel, and subscribe to the channel, and feel free to let me know if you have any questions. Okay, right, our focus is we basically want everybody to learn machine learning. We launched the lab in order to make sure the same thing, and of course it's we also need a little love from all of you in order to keep the show running, because we pay a decent amount to Google Cloud and Amazon Cloud. So feel free to subscribe to our lab. All right, we will be having this every week. So we are going to pick up another project in the next week and then move ahead. A question is, can you please show the output using the above model, how the actual versus the model house price is coming up after using the model? All right. Okay. So, all right, maybe some other time. I'll leave it to you, Pradeep. Try doing this, okay? I'll do this. So I'll explain to you. Just try to use the predict function in the last on the test data set and observe the actual value. Plot both of them using the Matplotlib, put both of them in an array, and then do that. Okay, so trust me, you'll be able to do it. Those who are wondering how to study, how to study pandas or Matplotlib or this, take a look at machine learning prerequisites and so on. Also, once you are confident about these technologies, do not forget to apply in the placement eligibility test. Okay, so we have launched placement eligibility test, whereby we take the test on machine learning and other things, and we basically put you in touch with the various employers. Okay, there, in case of placement eligibility test, we charge the employers, the people who are recruiting, not from the people who are taking the test. So be prepared, and that's going to be proctored. Therefore, your screen and the camera is going to be recorded, and it's going to be AI evaluated so that nobody is cheating in the class. Therefore, it's going to be helpful. So stay associated and with us. Right, we will be more projects are coming up. Feel free to share with your friends, and I hope this is good. Question is area under the curve. Okay, that we'll take another time. Okay, thank you everybody, and have a good day. Bye bye. Yes, wonderful questions. Have a good day. Feel free to share and subscribe.